We've made it to Chapter 12, Section 3C. Our objective in this section is to learn to identify slope, x-intercept, and y-intercept. Our essential question, how do I explain slope and y-intercept in context? You can graph a linear equation easily by finding the x-intercept and the y-intercept. The x-intercept of a line is the value of x where the line crosses the x-axis, where y equals 0, and the y-intercept of a line is the value of y where the line crosses the y-axis, where x equals 0. We're going to find the x and y-intercepts of a line, 4x minus 3y equals 12, and use the intercepts to graph the equation. We've already found the y-intercept from slope-intercept form, and that's still one way we can do that. This is another method if we don't want to change it into slope-intercept form. The x-intercept is the location where y equals 0. So to find the x-intercept, we simply change the y value to 0. So when we change y to 0, we end up taking 3 times 0, and that eliminates the 3. Then we're left with 4x equals 12. We divide by 4, and x equals 3. As an ordered pair, we would say that's 3, 0. If we want to find the y-intercept, that's where x equals 0. So we replace x with 0. We multiply 4 times 0 and subtract 3y equals 12. So 0 minus 3y is negative 3y equals 12. We divide by negative 3 to both sides, so y equals negative 4. As ordered pairs, x-intercept would be 3, 0, because remember we let y equals 0 to begin with. And the y-coordinate would be 0, negative 4. So we graph those 2 points, one on the x-axis, one on the y-axis, and we can connect our dots for our line. Let's try another one. Find the x-intercept and y-intercept of the line 8x minus 6y equals 24. To find the x-intercept, we let y equal 0. So we replace y with 0, we multiply to eliminate, we get 8x equals 24, and x equals 3. So as an ordered pair, just to point this out on this page, x equals 3 and y equals 0. For the y-intercept, we let x equal 0. So we get negative 6y equals 24, divide so that y equals negative 4, and we get our x-intercept and our ordered pair for this. X is 0, y is negative 4. You'll see some similarities in what we just graphed. We take our ordered pairs, and this equation happens to be the exact same location as the one we just graphed. The second part of this is looking at word problems and being able to figure out exactly what the slope represents and what the y-intercept represents. So in this example, a video club charges $8 to join and $1.25 for each DVD that is rented. The linear equation y equals 1.25x plus 8 represents the amount of money, y, spent after renting x DVDs. Graph the equation by first identifying the slope and the y-intercept. So we have the equation, which is always relevant. X is the number of DVDs, y is the amount of money spent, and we're going to graph the equation, but first identify slope and y-intercept. So we break down the equation. It's already in slope-intercept form. Y equals mx plus b. That means m, the slope, is $1.25, and b is 8, the $8 fee to join. So if you think about that, the $8 is the y-intercept because it's $8 just to start, but you don't pay that additionally. Then every time you get a DVD, you're increasing by 1.25 times that many number of DVDs. So let's go and graph that. So it's already broken down a little bit for you, but if you look closely, it's a little bit hard to tell on a graph like this. Our slope is 1.25, so we go up 1.25 and over 1 for every unit that it moves. If that's confusing, you could put that into a fraction form and do it that way. So as a fraction, 1.25 would be 5/4. So we should be able to look at, if we start here going up 5 steps, which would take us up to 13, and over 4 puts us on our next point. If we were to go from 13 up 5, that would take us to 18, over 4 would take us to 8. So by looking at it that way, we're skipping every other, but that doesn't mean that we can't still tell that those points are part of the line. It's more accurate to graph it with 5/4 because we know exactly how to go up 5 steps and over 4 versus 1 1/4. The y-intercept is the location we started at, so there's a reason that we didn't go any lower than 8, because you had to pay $8 to join in the first place. Let's look at a second example. A salesperson receives a weekly salary of $500 plus a commission of 5% for each sale. Total weekly pay is given by the equation y equals 0.05x plus 500. Graph the equation using slope and y-intercept. So our 500 is the amount that's the salary no matter what. So that's our y-intercept. 5%, when we use it in an equation, we multiply with the decimal, so 0.05 would be our slope because that's per amount that that person sells. So when we go to graph this, we're going to be graphing B 500 first, and from there going up 0.05 and over 1, which if that's a challenge for you, figure out what fraction that would be. As a fraction, that would be 5/100ths or 1/20th, so you could go up 1 and over 20. So to make this graph a little bit easier to read, we start at 500, and if we're going at a pace of up 1 over 20 for our slope, you might want to figure out, okay, how'd they get to 5,000 here? So let's look at it as going up to 50. So if we're going up to 50, then if we multiply that times 20, then we're going to end up at our 5,000 mark. And so then we would take an equal step equal to that. If we go up another 250, we go over another 5,000, up 250, 5,000. So when we're working with larger numbers and we have a small slope, you can make it into an equivalent fraction that's closer to the numbers you're actually working with. That's it. Make sure your notes are filled out completely. Go back to anything that you need to review in this PowerPoint, and good luck on the practice.